Hey, Paul here at VintLabs. How you doing? I just wanted to quickly go over a new product we have going on here. So I got this little ESP32 Zip. So really just a basic kind of standard ESP230 or sorry, excuse me, ESP32 Devkit. So for those of you familiar with ESP32, don't need to go into that, but if you're not, well, maybe we'll go over that a little bit better on another occasion. So, but briefly, dual core processor, runs 3.3 volts, tons of GPIOs, absolutely tons. What is it? And there's capacitive touch sensors, PWM outputs, and on and on and on and on. And a couple things different from this one from some of your run-of-the-mill ones like these guys is actually a big difference for me anyway. Is we changed the it's got a different voltage regulator. They that 1117 voltage regulator on most of them. They like to call it an LDO, low dropout regulator, but they really not because they drop about I think it's a 1.25 volts, so which pretty much excludes the idea of running that from a single lithium battery. Where on here I use the AP7215, so we get something like about 0.25 volts of dropout through that. So you could really run this off a battery. There is no charging circuit on here, by the way. But aside from that, pretty kind of standard thing. It came out a little bigger than, say, some of the other dev kits, but not too bad overall. And a little history on where this came from is using, using these guys. These guys are great if you want to stick them on a breadboard, screw around, do some testing and whatnot. But I found that in production they're not very good because, well, the pins are all exposed. And, you put it somewhere, a screwdriver falls on top, who knows what. And I don't know, they're just kind of terrible for that. And it reminded me when using Raspberry Pis. I got a Pi Zero wireless here, which I really like those things. They're pretty slick. And got some of those, and then I got myself, one with a case. So case isn't enclosed here. I got a funny header on that, but you get the idea. And I really like those. And I thought, why not put ESP32 on one of these boards? Behold. So when we designed these, the the cost actually ended up going up a little bit more than I hoped because the space constraints, because of that width, could not get the ESP32 device far enough away from that header to effectively route all the GPIOs up there on a two-layer board that is. So I had to go to a 4-layer board, up the cost a little bit, but I felt it was worth it. I really like this. So now we can just get in there, snap it into the case, and Bob's your uncle. You can have a couple different covers, ship with or without the cases, by the way. Have a couple different covers if you don't need any add-ons, any IOs on it, or if you just want to drill a couple holes in there for 2 wires going out or whatever, you can just snap on the solid cover. Most commonly, I find I use this cover, and works out pretty slick. So you still have access to all your IOs. I'll show the pin out here momentarily and link to that online too, down below. And just a little overview here though of our connections. When you're looking through the holes of the case, we have our USB for programming and serial port access. That's the 2 buttons in there. Can we see that? I think we can see that. There's the enable button here. Maybe if I point with something smaller, my finger, it'll help. The enable button here and the boot button here. And you got to kind of reach through and push them, kind of standard fare. This port here is originally for the HDMI output of the Raspberry Pi, and I didn't really find any good use for that port, but it's okay there, I'd say. And at some point might make some slightly different cases, but for now, I'm just using the standard issue official Raspberry Pi case, and they work pretty slick. I mean, we'll plug it in and give it a go here. Oh, you can see that one's already programmed. So actually on the board there, you can see it through the hole there. Let me just grab another one so we can see. I don't have one. Where is it? Here it is. I get focused, and we have darn focus. Come on, and just a quick run through. There's the LEDs in the thing. There's a power. You know what? I'll power this one up. That might make more sense. Eh? There. Must already have the old blink thing going there. So over on this side here, we have our main power LED, which incidentally you can disable on the back. Let me see if we can focus on that. There's a jumper there. You can just cut out the little traces between the two portions of the jumper. That'll disable that LED, which you might want to do if you're running on battery, because it's a fairly high drain. So really, I try to minimize the brightness and as such the power use of the LEDs as much as I can, but I left these a little on the brighter side. So anyway, so we have that LED there up at the top here. You can see we have, oh, forgive me, this is a revision B board, so the labeling and a few things look a little different, but that's okay. We have just a utility LED there, the blue one, and then there's the green and yellow ones for transmit receive on the USB bus, the serial transmission that is. So let's pop the cover off this one, so I'm not showing you the revision B one. It's almost identical, but just not quite. I didn't sell those, by the way. I wasn't. Okay, we got the cover off there again. Jam the USB in. Okay, let's try to have a little looky here. Yeah, probably would have been easier without that. I don't know if we can see that there, but it is labeled in there that the utility LED, the blue one, just under the header there, you might be able to see GPIO2 just for reference. And as I said, there's the green and yellow here, the transmit and receive over USB. And, well, we'll see that in a second. So, maybe what we'll do is we'll just load up the standard Blink sketch just for laughs, just for completeness. Just fire up the Arduino environment. Okay, so then we'll open, just go examples, whoops, examples, basics. Come on. Pardon me, I'm sitting way off to the side of my screen here. So, boom, and you'll see in the standard Arduino sketches it has the LED built in. We don't have LED built in defined for this board. I might do that at some point, so I just simply redefine it. LED build, whoops, come on fingers, built in 2. And then what we need to do, if this is your first time programming the board, is in boards, go to board manager. If you have not installed ESP32 Arduino environment, you'll have to do that all in advance, or else you won't get the ESP32 boards. And if you go to the board selection and scroll down, whoops, on the boards, and scroll down and down, and way at the bottom, you see the VintLabs ports. Select that one. Make sure your port's selected. USB 0 on mine. If you're Windows, you may have to fish around to see what your COM port is. I don't know. The upload speed, I generally leave it at 2 megabaud. Seems to work great. So, okay, well, let's upload. Boop-a-doo. And give that a moment. And you'll see the USB transmit data LEDs toggling there. And maybe I should have changed something so you could tell that happened, because we already had this loaded. Let's just change one of these to 100 milliseconds. Control U, upload. And programming. And yep, you can see quick little flash there now. Very exciting stuff, eh? Well, maybe we should try something a little more fun. Just as a little extra demonstration. Where'd my lid go? There it is. Oh, excuse me, it's wandering away. I should have put the rubber feet on there. Comes with those. Higher. And snap. In you go. Okay. And we also have, I haven't actually shipped any of these out yet, but we made this capacitive touch sensor board. So basically I've got 3 buttons here. I just gave them kind of generic symbols. So, like it could be, I don't know, left, right, and enter or something, or up, down, whatever. It doesn't really matter. It depends on your orientation, your desires. Got a reference on the back for each of the capacitors. That's touch input 9, touch input 8, touch input 0 over there, and there's also 2 LEDs on there. I'll show you those in just a second. Let's just snap that on there. There we go. Pretty cool. And maybe I should have, I think I had that right here. Yeah, there we go. Just a simple little demo here for that. Just to go over it quickly. Just the simple capacitive touch test for that thing. And it starts the serial port, usual stuff. Set the 2 LED pins, there's pin 13 and pin 15. Set them as outputs, and then in the loop, just set up a couple variables. I did a little loop here. I set a count to 20 and read each of the, so you do the touch read that reads the capacitive sense input for each one of the 3. I just added them up, and then, where did I do that? What did I do? Oh, I divided down there. That's unusual. I don't know why I did that, but anyway, it doesn't matter. So I read them each 20 times just to get a quick little average out, just to remove a bit of noise. And then on each of them, I just checked if T0 divided by the count, because I need to average it, is less than T, the little threshold here, which I set at 32. You might have to experiment a bit on that. Here, actually, maybe we'll just do that right here. And let's just get rid of those. I don't know why I do that. I should do this so that you can just set a debug on or off. So anyway, just reads through each of them, and if touch 0 is below the threshold, which means it's touched, it sets the LED at GPIO 15 high. Whoops. And if touch 8 is below the threshold, meaning touched, it sets both of them high, turning the LED on. And if touch 9 is there, it turns just the one on. And a little delay in the loop, not much. I'm not sure. Probably doesn't really make any difference. Anyway, let's just upload that and have a little looky here. Oh, we there? Okay, yep, we're done. So, you see your touch that one. Both LEDs come on. Touch that one, just the one. Touch that one, just the one. You're just a little. Oh, I could play with that all day. No, the touch sensors are actually, they can be quite handy for some instances. So, as I mentioned, there's the threshold in there, and if you look at the serial console, let me bring that up, Control M. It should show me what my touch values are for at least one of them, I can't remember. And the touch value is, oh, I didn't actually display that out. Yeah, maybe we'll just print out the values for T0. Excuse me, my keyboard's wobbling here. 9 and what was it? T0 divided by count. I don't know why I didn't divide that up above. It's okay, it's just an example. And we'll re-upload that, open up the serial console. Okay. So you see our values are floating, I don't know, I'll call it about 70. And, whoops. And when it's touched, what are we looking at there? 7, 8. That was my whole thumb across it. Just a tip of my thumb, about 18. Try to tip my other finger just for fun. That's in the 20s. So, whatever you can play around with that. And depending on environmental conditions, could actually even change it ever so slightly. So, if you find the lightest smallest touch on it you can get. Like, for example, if you just kind of, if you want that to work, check your value there. And in my case, I don't know what that say, high 20s. So set the threshold, maybe just a wee bit higher than that, but much lower than the not touched one. Typically, maybe something like half the value of what it shows when it's not touched is about good. And then, so otherwise you can end up with, spurious actions coming from, random factors, let's just say. Or when you touch the one next to it, it could trigger that one if your threshold's a little too low, or sorry, too high. But anyway, I thought that was pretty cool. So maybe what we'll do is we'll kind of have a little look at the pinout for this guy. Whoop! It's hard to do that around the camera. Here, let me just unplug that so we don't have the flashing lights in there. So when I did the pinout for this, I tried to do it very similar to how the Raspberry Pi pinout works. Kind of with the hope that maybe some Raspberry Pi hats will work on here. I do not recommend just plugging one in. You really want to check the pinouts and the current requirements, and make sure it's 3.3 volts because the Pi, if I remember correctly, up in this corner has a 5-volt pin, but on the ESP32 that'll be 3.3. There's no 5-volt output on that. That possibly could change in a future revision. I might just to line it up with that, but not sure about that. I don't know. So anyway, so for the pinouts, I kept the first 5 pins here to function basically the same on the ESP32 as on the Raspberry Pi. And, excuse me, get one of these. Primary reason for doing that is I've made a bunch of little sensor boards. Let me see that? Yeah, there we go. And this one is the MS5607 barometric pressure and temperature, so altitude sensor board. Forgive the crappy soldering on there. A lot of the boards I keep around here are ones that have been reworked and whatnot, so they don't always look the best. So anyway, these are designed with this header to be able to plug straight on there. Whoop. Dang, that's hard to do around the camera. Okay, so that can plug on there, and then another one maybe could plug in up here. Which way are you? The right way? No, this way. Because these are I2C devices, you can daisy chain them. So anyway, I'll get into those maybe in a separate video. But additionally, on the board, I did have this VN header here. So you could, instead of supplying the power from the USB, you could apply 3.3 volts, or 3 volts would be fine too, whatever. I can't remember the exact range, but so if you can put your 3v3 plus right there and ground right there, you can power the board that way as well. Anyway, okay, that's about that for there. And anyway, just a little tip: getting these boards out, pull out a bit on the case back there, and it pops right out. First, while I was messing with these, that really messed me up. Oh, I did forget to mention the for USB drivers, it's a CP2102 on here. So same device as most of the other ESP32 Devkits use. They got the QFN28. I use the 24-pin package. I'm not sure why they use that on there. I can never really figure out, although it does seem to be a little more available. So it could be as simple as that. Okay, maybe we should have a little look at the pinout on this guy. So if you go to, let me get it ready here. Go to vintlabs.com, or sorry, github.com/vintlabs. You can, and then find your way down here. Let me just go. And I don't know, the order of this might change, but anyway, find the ESP32-Zip, and that's our board we're working with here. And right on the main page there, you'll find, scroll down and down and down, a pinning diagram. So pretty standard stuff. It's like I mentioned before, I did try to keep it similar to the Raspberry Pi pinout as much as possible. There were some variations in that. And again, please don't just plug in a Raspberry Pi hat without checking stuff first. So you see the first 5 pins, actually that's right in here. Up here, up here, up here. That's what I find I use most because I can usually take care of most of my stuff there because you have your 3.3 volts, GPIO 21 and 22, which for on the I2C bus, that's your SDA and your SCL, and then GPIO 23, I just use it as standard IO and then a ground. So I just, those are the ones I find I tend to stick with most often. And just a couple notes on here too. You'll see I have the ADCs, blah, 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 blah. All the touch inputs here, touch 9, touch 8, touch 7, 6, 5, 4, da da da. And, well, that wasn't touch 4, it's over here, that's okay. And do take note, though, of the ones that are labeled input only. That's not only for this board, that's something kind of designed into the Room 32 modules. So, cannot use those to drive LEDs or whatever, only for inputs. No big deal, but just something to be aware of. And just also take note that it is, there, see, open hardware. So, and if you go on to GitHub, you can find the schematic here. I don't know if I've updated that. I don't think that's been quite updated for Rev C yet. I'll try to make note of doing that after. However, if you could check out the source, you can open it up in KiCad. And let me clear those things. There we go. Sorry about that. And there's our schematics. Have our CP2102 and USB stuff up here. The voltage regulator, convert the 5.5, or excuse me, 5 volts to 3V3. Our buttons over here, the enable and boot buttons. These LED LED, our 2 LEDs for the USB activity. This is the circuitry to handle the reset and boot reset and download mode, I guess, for just like you'd press the boot button, which is handled by DTR and RTS over serial when you're programming the board. Don't really need to know all about that. It should just work. Normally does. And we've got our Room 32 device, the ESP32 MCU on inside there, and our main connector right there. And a good, if you're familiar with KiCad, I find if I need a pinning reference and I really want to visualize it, opening up the PCB file, I find is the best way to do that. I can really find I can visualize it better. So when you open it up, you'll probably have all the copper layers enabled. If you take out the 2 internal layers, it makes it much easier to look at, or actually even if you just take them all out. Makes it a little easier to look at, then you can see, oh, okay, well that's, IO26 is right there on pin 23. Okay, anyway, I just wanted to do a quick little overview of this guy. So, as of right now, kind of popped out of the case there a little bit. Get back in there. There you go. And it is available on Amazon Canada only, unfortunately, at the moment. I will change that at some point, but I don't know. I live in Canada. It's just a lot easier just to ship just to other places in Canada. You can also order it through my website online. So, oh, I got him in there backwards. Anyway, doesn't matter. So just a little look at the back. So just for reference, we have the, get my fat finger out of the way. Where's my pointer? I did put a URL where the pinout can be found, and URL for the forum, and my GitHub link. A little note here to open that jumper, disable the power LED if you so desire, and just a little warning there too, which I should have mentioned earlier. The V in there, don't connect power in there when you plug down USB. It'll try to connect straight to the 5 volts on the USB bus, and bad things might happen. So, don't. And and also of note, I left connections here, so you could conceivably connect a SD card to here. I haven't made a little module for that yet, but probably will do that at some point in time. Just another little point of interest. Things I use this for. I use it for data collection for temperature and humidity, different places in the house. We have a cold room, and and the basement, upstairs, that sort of thing. I keep track of what the temperature is everywhere. Actually, and I should do a separate video on this. I set up a water sensor on the floor. Basically, all I did is connect a wire from one of the touch inputs and put it on the floor. And I can't remember what the readings are, but let's just say when everything's dry, it reads 50, but then when it gets wet, it starts reading like 7 or something like that. So I set that up with an alert, and it actually sends an email with an SMS. So I definitely should do a video on that. It'd be very cool. I find that really useful and comforting to know that if I'm out somewhere and the basement starts flooding, I'll get a note and you can go address it. Anyway, hope you enjoyed that, and if you have any questions, you can leave comments down below, or go on over to the forum, vintlabs.com/forum. You can leave comments and questions there. Direct issues with the hardware, if you could leave a GitHub issue. Doesn't really matter too much to me which way you do it. I prefer all those methods to direct emails, just because it keeps it public for other people to see for the future. Anyway, hope you enjoyed that. Have a good day. Thank you.